So we've seen we can overlay plots, we can do plots side by side in different windows, we can control the scales on the axes in order to zero in on how we want to do comparisons of displays. We can add labels, we can add legends, we can add titles. We're in good shape. Let's think now about how we might actually control even more of the parameters of the different displays in order to better highlight different aspects of what we're trying to plot. So we might want to change the color ourselves of what we're drawing in, or the style of the data sets. We might want to change the width of the lines to highlight one more strongly than another. And we might actually want to do subplots inside of a plot. Let's look at all three of these things as different ways of using plots to visualize data. I'm going to start with changing the data display. And in particular, I'm going to go back to my similar examples. There's a lot of code here, but we've seen most of it. I'm going to open up a comparison of a window that's going to compare linear and quadratic. I'm going to clear it as I did before. And now when I'm going to do the plot, I'm going to add in one more piece. I'm again plotting my samples against linear or my samples against quadratic. We've seen the labels as before. The new thing I've added here are strings that specify the color and the style on which I want to do the display. They're a little terse, that's okay. I'll let you go look at the documentation to see your choices, but the first part of the string says what color to use. B, I believe, is blue, R is red, G is green, R again is red, K is black for reasons I don't know, but the designers of PyLab do. Basically, you can look up the choices of those. The second part of the string lets us decide how we're going to do the display. So a single dash is a line, a zero is a circle, a little upper arrow or caret is a triangle, and two dashes is literally a dash. The idea is that the third argument is going to let you specify a string that says here's the color and style to use. I can still add in other keywords like label to override this. With that in mind, let's see what happens if we do the display. Ah, cool. And notice, by the way, the legends nicely reflect this. They also say, here's what we're displaying here. So now I've got a dotted line compared to a straight line. I've got a dashed line compared to a sequence of triangles. I'll let you do the exploration of other kinds of variations you could try here, but you've got some control in how you want to highlight how you're actually visualizing things. In a little while, we're going to come back and use this as an example to see how this is really handy to capture different aspects of data. But you can see I've got the ability to change the visualization. So I can change the style in which I display things. What else could I change? The second thing I could change would be actually the line width. If you like, how thick a pen or how thin a pen am I using to draw these? And here you can see I'm simply adding in now one more keyword, line width, not surprisingly, and I'm giving it a size from 2, 3, 4, and 5. This is referring to the size of the pixels, if you like, on the graph that I'm using to do the display. Everything else here is the same as before. Let's see what happens when I do that. Yeah, very nice. Now you can see, again, the legend picks it up. Notice over here, exponential is a very thick line compared to cubic, compared to quadratic, compared to linear. And it's simply another example of being able to change the aspects of the display to highlight things I want to highlight. I could have picked something different. This is just a nice way of showing it off. The last thing I want to show you in terms of controlling displays takes a little bit of explanation, and that is to use subplots. So some of this is as before, creating a figure, I'm clearing it, but now I'm going to give it a call to subplot. And the subplot takes as arguments three numbers, which will look a little bit interesting. So let me tell you what those three numbers are. Those arguments are the number of rows and the number of columns inside of the plot, and then which location to use. So in these top two, I'm basically saying inside of this figure, same figure, I want you to display something with 2 rows and 1 column. So 2 graphs like this. Down here, I'm saying do something with 1 row and 2 columns. So something that's going to look like that. We'll see that in a second. And then the third argument is saying which location am I using in terms of that display. I'm going to do one other thing here. I'm going to go back to that idea of controlling the range or the limit on the y-axis because I know that these are of different sizes. In this case, setting it to 900. Down here, setting it to 1400. And with that in mind, I'm going to actually go ahead and do the display. Now notice I've got a call to y-lim after each of the subplots in order to try and do that kind of a display. I'm setting the limit within each subplot. I don't have to always do that, but that's a handy way to just make sure I'm being careful about how I'm doing those kinds of plots. Okay, let's see what it looks like. Exactly as I described. In the first case, I've got one column and two rows. In the second case, I've got one row and two columns. And the reason I picked setting the limits is so we can see the comparison here in the growth, because it's the same y in both of these cases. And similarly over here, I've picked the same y for both of those cases. You can also see a personal choice here. I don't particularly like this style because I start getting overlaps of values on top of the actual graphs. I find this comparison a little bit better to use, but it's your choice. Main point is I've got the ability to compare things side by side or top to bottom. My choice, but another way of thinking about using aspects of plotting to visualize the data. Now, we've seen a lot of examples of actually doing different things, looking at these different four very simple orders of growth: linear, quadratic, cubic, and exponential. Let's now switch gears and think about using the tools we've seen here to actually think about how do I visualize data and think about computation as part of that visualization process. Before we get to that idea of doing that visualization, though, let's look at one last thing that we can do in terms of changing things here, and that's to change the scales. And changing the scales here basically says, if I've got something that actually grows really rapidly, rather than plotting them linear and linear, I could plot them where one of the axes is done on a log scale. And I use the call y-scale, giving it the argument log, to tell me that I want to use a log scale rather than a linear scale as I do this actual plotting. Everything else is as before, and now when I plot them, I can see I can compare simply linear comparison against logarithmic comparison here. The reason this is handy is something like exponential grows so quickly that it really swamps out things very rapidly. And you can actually see it here, even with this rapid rise. When I plot things on a log scale, which is each incremental step here is an increase of an order of magnitude, I get a different way of seeing things, so that now the exponential is linear on a log scale as it should be, and the cubic starts to drop off much more rapidly. So that idea of being able to change scales lets me focus in on orders of growth in a different way.